We not only can overload regular methods, we can also overload constructors. So for example, in the class moose, we can have two constructors of moose as long as they have different parameters. If we instantiate moose with a hamster argument and a rat argument, then the compiler knows this invokes the moose constructor, which takes a hamster parameter and a rat parameter. Often when a class has more than one constructor, the constructors mostly do the same thing. So it makes sense that rather than duplicating this work, one constructor can call another. Here, the moose argument, which takes no arguments, is invoking in its first and only line the other moose constructor. Notice though that the syntax for this call is special. It uses the reserved word this followed immediately by parentheses with a list of arguments. What will not work is to invoke the other moose constructor using the new operator. This is perfectly legal code, but it would create a new second moose object, which is not what we want at all. Nor should you invoke the other moose constructor by using its name. This would arguably be perfectly sensical syntax, but Java chose to use this instead, so this isn't legal code at all. So, when one overload of a constructor wants to pass part of the job off to another constructor, you invoke the special reference this like it's a function. Another thing a constructor might do is invoke one of the constructors of its parent, and this is done by invoking the reserved word super. So here in the first line of this top moose constructor, we are invoking the argumentless constructor of moose's parent. This makes sense because when you extend from another class, you still want all of the setup work that's done in that parent class to also be done for all of the children. You just want the children to do additional setup work. So for example, if we have a hierarchy of Kate inheriting from Ted, which inherits from Jack, which inherits from object, then when we construct a new Kate object, first the constructor of the object class should do its business on the new Kate object, then the constructor of Jack should do its business, then the constructor of Ted, and then finally the constructor of Kate. Well, it turns out that Java makes sure this is always the case with a few simple rules about constructors. The first rule is that constructors are only invoked via the new operator or via the references this and super. Second, invocations of this and super are only allowed as the first line of a constructor. And third, the first line of a constructor always invokes this or super. Never both, just one or the other. So in fact, when you see a constructor that doesn't start with a call to this or super, what's really going on is that by default, it is invoking super with no arguments as its first line. Because a constructor can only invoke the other constructors of its class as the very first thing done in the constructor, then any kind of recursive invocation of the constructors would end up being infinite. So for example here, if the moose constructor with a hamster and rat parameter invokes the moose with no parameters, and the moose with no parameters in turn invokes the constructor with a hamster and rat parameter, well then if we create a new moose object using either of these constructors, they're just going to keep going back in circles. It's going to be infinite recursion, and that's obviously not desirable. Consequently, Java has a rule that calls to this cannot be recursive, either directly recursive or indirectly recursive, as we just saw in the previous slide. Finally, the last thing to know about constructors is that if you want them to return early, you just write a plain return statement with no expression for a value. The way Java thinks about a constructor is that it doesn't actually return anything. When you create a new object with the new operator, it's the new operator which is returning the new object, not the constructor. So when you return in a constructor, you could just write return semicolon.